Today we're going to talk about casting and type conversion and the difference between them. Generally, they both refer to converting one data type into another. Anyway, type conversion is done whenever the two data types are compatible one to another. There is no danger of losing data and is done automatically by the compiler. Here we can differentiate between casting and converting in the sense that conversion is done automatically by the compiler while casting is explicitly done by the programmer. Conversion doesn't use any kind of operator since it is done automatically by the compiler. You probably remember that in the previous lessons we displayed on the screen some text and the value of an int variable in a single sentence, and I was explaining that the compiler automatically converts the int type to a string type that can be printed. In that case, there was no conversion operator involved. We only used quotation signs, which delimited the start and the end of the string literal, and the plus operator for joining or concatenating the text together with the int variable, but we haven't used any specific code to convert the int to a string. Casting, on the other side, since it's been done specifically and manually by the programmer, uses the casting operator, which is a pair of starting and closing parentheses that comprise the type into which the programmer wants to convert the value. Since it is done manually and it's implied that the programmer really knows what he or she is trying to do, casting allows us to use a destination type that is smaller in range than the source type. Take a look at this example. So first, let's draw a small graphic of the range a byte and an int can store. Of course, this is not a very realistic scale, but anyway, we have the int, which ranges from -2.1 billions to +2.1 billions, and we have the byte, which goes only from 0 to 255. It is only obvious that the range of the byte is contained inside the range of the int, so if we want to give the value of a byte to an integer, there won't be any problems. But if we try to do the inverse operation of giving the value of an int to a byte, yeah, that could work if the int value is in the range of 0 to 255. But if it isn't, we would get the overflow exception I explained in the previous lessons. In other words, we would want to convert an int to a byte. There is always a danger that the int value could be outside of the range a byte can store, and that would result in loss of the data. However, if we try to convert an int value that is in the interval of a byte, the conversion works just fine. However, since there is the danger of data loss, the compiler doesn't allow us to directly try and give a byte the value of an int. We have to tell it that we really and intentionally want to do so, and that in the case of data loss, we assume the responsibility for the error. Yes, I can fire this gun, but you have to take the safety off, and if you shoot yourself in the leg, well... There's another difference between casting and converting, also related to the range of types. Since a conversion is only allowed when we are converting a type from a narrower range into one that has a wider range, this process is also called widening conversion because obviously the range of the small source type fits comfortably inside a bigger range of the destination type. Complementarily, a narrowing conversion is a name given to the transformation that occurs during a casting when we can transform from a wider range to a smaller one. The way we specify a casting operation is by using round parentheses in front of the type we want to convert, and by specifying between them the type into which we want it to be converted. Actually, even if casting sounds a lot like a type conversion, in most cases there is no conversion involved. We are actually just explicitly telling the compiler that it should look at our data in a different way. If we want to see an example of conversion of actual data manipulating by the compiler, we only have to assign the value of an int to a float. Even if the operation is permitted, even if there is no danger of data loss, since float has a much larger range than an int, and since we already know from the previous lessons that the way an int and a float are stored in RAM is very different, with all the exponent and the mantissa stuff, the compiler must actually perform some actions of the bits of an int in order to be stored like a float. And I can even show you this by offering you a look at the RAM addresses where these two variables are stored, and making you see that even if they have basically the same value, the data representation is completely different. But this is already advanced stuff and you shouldn't concern yourself with this. I am only showing it to you to prove a point. So this is the assembly window, which are the most basic instructions for a microprocessor that are still readable by humans, and they get translated into machine code. As we will learn much more later, our C# code is converted into what is called Microsoft Intermediary Language, which is a platform independent and can run on any CPU, and this intermediary language needs to be further compiled by the CLR, using the just-in-time compiler, or jitter in short, into native code, which we see here represented as assembly of instructions. In the other panel, we are actually seeing locations inside the RAM memory and the values they are currently storing. If you look in the assembly panel, we see our int variable declaration and initialization, which gets translated to the assembly instruction, and we also see the declaration of the float variable, including the assignment to it of the int variable's value. And you notice this requires a lot more assembly instructions. And finally, we have the line where we convert the float value back into an int. Now, I know we haven't talked about debugging yet, and this probably seems like gibberish to you, but in short, debugging allows us to actually run our program instruction by instruction, pausing after each of them so we can analyze what happens with our codes. I'm going to set a breakpoint here, which means that the execution of our program will pause as soon as we will reach the line of code. Now, this little hexadecimal value here actually represents the RAM location where the value of our int variable is stored. And if we copy it and go to the address, we see that now it has the value 0 because the instruction that assigns a value to the int variable has not yet executed. However, as soon as we run this instruction, there it is. We have the value at the RAM location. The next 4 bytes above the address are the bytes where our float variable is stored. Remember, a float also has 4 bytes just like an int, but it's stored differently inside the RAM. And yes, the addresses go upwards because of a thing called the stack, of which we will learn much later. Anyway, if we execute the next instruction, we see the value of the float variable changing because we assigned the int value to it. It looks weird inside a memory due to the fact that it is represented as a hexadecimal value, and this is true for the int variable too. Each 2 hexadecimal digits represent a byte of memory, so 4 bytes of RAM are represented as a series of 4 groups of 2 hexadecimal values, yada yada yada, not important stuff to you right now. What is important to the fact that, although both store the same value, the value is represented differently inside the RAM, and that demonstrates the fact that when we are explicitly casting a type inside another type, we're actually performing some operations on those bytes. They get changed in order to accommodate the way the new type is represented in memory. Like in our case, we converted an int, which is represented directly by 4 bytes, into a float, which has a mantissa and an exponent, so it is not directly represented as a straightaway value. This lesson may seem complicated, but you only need to retain 2 things. Whenever there is no risk of data loss, you can use implicit casting. On the other hand, when you perform a type of conversion that could lead to overflow or underflow, you need to use explicit casting. Hopefully this lesson will be any use to you and will explain some of the basic inner workings of C#. Have a nice day or evening, whatever. Bye!